In this chapter, we will examine the question of whether two variables are associated. The question of association comes up all of the time. Is income related to education? Is height related to nutrition? And so forth. Previously, we have described only one aspect or variable of a population. Many study designs, such as the ones we will examine in this chapter, are aimed at examining the association between two quantitative variables measured on the same subject or object. These are called bivariate study designs. As you may know, the prefix bi stands for two. The graphical technique that is most often used for displaying bivariate data is called a scatter plot. Scatter plots are tremendously helpful in identifying trends in the data and also potential outliers in our data. Here is our first example of a scatter plot. We have gathered data on 29 subjects. We have recorded both the age of the subject and the systolic blood pressure of the subject. Notice that both are quantitative variables. The age is measured in years, and the systolic blood pressure is measured in millimeters of mercury. A scatter plot is a two-dimensional display. Age is displayed on the x-axis or horizontal axis, and systolic blood pressure is displayed on the vertical or y-axis. This was actually not an arbitrary decision. The objective of this study is to predict a person's systolic blood pressure based on a knowledge of their age. Age in this case is the explanatory variable. We're trying to use age to explain this response variable, systolic blood pressure. It is the convention to always place the response variable, the variable we're trying to predict, on the vertical or y-axis. And the variable that is used to do the predicting, namely the explanatory variable, is placed on the horizontal or x-axis. Some studies are aimed at predicting the value of one variable using the value of an associated variable. In these cases, we need to identify which is the response and which is the explanatory variable. Others are simply aimed at looking for potential associations, and the choice of explanatory and response variable is arbitrary. So let's get some experience deciding about explanatory and response variables by looking at a few examples. Our first example, we're looking at the serving size of an ice cream cone and the calories of that ice cream cone. I would imagine that we're trying to predict calories based on serving size, and hence the serving size is being used to explain the number of calories. What about the gas mileage of an automobile and the weight of that automobile? What are we trying to predict? Probably the gas mileage based on the weight. Explanatory weight, gas mileage response. The price of a theater ticket and the number of tickets sold. Well, if I'm the manager of a movie theater, I would probably want to predict my sales based on the price of the ticket. Price will be used to explain the number of tickets I sell. I would imagine the higher the price, the fewer the tickets I'm going to sell. And finally, the age of a husband and wife at marriage. In this case, I don't see any clear choice of an explanatory or response variable. We're probably just interested in whether there is an association. We'd like to be able to describe our associations as either positive associations, negative associations, or potentially no associations. So as we look at the scatter diagram of age versus systolic blood pressure, I'm noticing that the points are rising to the right. When the points rise to the right, which corresponds to an increase in age resulting in an increase in systolic blood pressure, we have what is called a positive association. Here is the data for a number of automobiles. We've recorded the weight of the automobiles and the city miles per gallon of the automobiles. And here is the resulting scatter plot. You'll notice in this case we have the opposite kind of association. The heavier your automobile, the lower your city miles per gallon. Our points in this case are falling to the right, and we're going to describe this as a negative association. As one variable increases, as your explanatory variable increases, your response variable decreases. So this slide pretty much sums it up. A positive association exists if when one variable increases, so does the other variable. A negative association exists when one variable's increase results in the decrease of the other variable. We go on to examine a few examples. How would you classify this graph? The points seem to be rising to the right. If we were to think about superimposing a straight line on this data, I would classify it as not a strong relationship, but perhaps a moderate positive association. Here it seems as if the points are falling to the right. So we'll describe this as a moderate negative association. Can you see why we described the previous one as moderate? Here we have our points rising to the right, but the trend seems to be stronger. So perhaps we could classify this as a strong positive association. And the next one as a, what do you think? Strong negative association? What about this one? In the beginning portion of the graph, the points seem to be falling, then they seem to be rising. I think the fairest decision here would be no association. And we leave with considering this data that we've seen in a previous chapter. The monthly temperatures in Raleigh, North Carolina, for the months January through December. There is clearly a trend to the data. The temperatures are rising. They reach a maximum around June, July, and then they begin to fall again. But this is an example where there's a trend to the data, but the trend is not a linear trend. We're going to limit ourselves in this chapter to describing linear trends. So to sum it up, we've seen that associations can be strong, weak, or non-existent, positive or negative, linear or nonlinear. We will later go on to describe measures of the strength of the relationship. This ends our discussion on scatter graphs.